Hello beta, welcome back to my channel. One second. So let me know if I'm audible or not. Let me know about the class. Am I audible and visible to all of you? Am I audible and visible? Yes. I'll check by my own end. Mandeep Dayama. Hello beta. Ankush KR. Hello Hasana. Hello beta. Yeah, I am. Okay, great. So that means you are very ready for this particular class, right? Okay. Yesterday, due to some sort of technical issue, right, something happens with the class, but today we are very gear up for the class, right? So let's continue session now. Okay, if you were present, hello beta, if you were present in the last class, no, we discussed it about a magnetic effect of electric current. Then we discussed it about what? Do you have any idea? Biot-Savart's law. Done, no? That the magnetic field is proportional to the current element angle divided by the distance square. That is nu naught 4 pi I dl cross r divided by r cube. Okay. Then we discussed about the application part of Biot-Savart law due to a straight conducting wire. Okay. Nu naught I 4 pi d sine theta 1 plus sine theta 2. Then we have sub cases. That means if the wire is infinite, so you need to place theta 1, theta 2, both 90-degree. Place it. If we need to discuss a semi infinite, theta 1 is 90, theta 2 is 0. Okay. Hello beta. So in this way now, we discussed a lot of things. Now we will start today's class by doing simple numerical, with which you will get a recap. Okay, you will get a recap. And if you have any doubts from previous class, you can ask me in this live session. Okay, now, if we are having a wire, this wire, here I need to find a magnetic field. This distance is A. The line is finite, but we don't have idea about the angles. This angle is theta 1 and this angle is theta 2. Current I is flowing. Done. But this length is given to us. This one is 3 by 4a. In the similar way, this length is given to us. This is 4 by 3 times a. Now, do you know the equation that we need to use? Yes, sir. We need to use b equals to nu naught I divided by 4 pi distance, that is a. Then we have sine theta 1 plus sine theta 2. Basically, this equation we need to use. You can see, sir, nu naught is constant. Okay. Sir, I is constant. Okay. Sir, 4 is constant. Done. Sir, pi is constant. Done. D is distant. That means here, if we can check now, sir, D is equals to A. But we don't know what is theta 1 and what is theta 2. Sir, no issue. So if we are having something like this, look now. Okay. One second, beta. If we have something like this, no? Okay. And you can see now, this side is 3 by 4a. This one is theta. Okay. This one is, you can ask me. No, you can ask me. Okay. No, no, sorry. I forgot to just change it. No, so I was doing it. With 1 second. Sorry, I was not. I was just differently. I was just teaching you stuff, but it was not visible, right? So you can see. You can see now the screen. But you can ask me. There's no issue, na. You can ask me, na. So I was just teaching you, but you don't just tell me the screen is not visible to you. Okay. Basically, we have this numerical, and theta 1, theta 2 is not given to us. We need to find theta 1 and theta 2. Sir, how we will get theta 1 and theta 2? So we can make a triangle, this one now. You can see this theta we need to calculate. Okay. This side is 3a by 4. Yeah, but that's possible. Now, if this one is theta and this is 3a by 4, so could we write tan theta? This one is a now. Tan theta. Is it p by b? Okay, what is p? P is 3 by 4a and b is a cancel out. Now my tan theta came out to be 3 by 4. So theta is 37 degree. If theta 1 is 37 degree, which implies that theta 2 is 53 degree. So all unknowns we know now. So I can write nu naught I divided by 4 pi, it is a. Then what we have, it is sine 37 degree plus sine 53 degree. So I can write nu naught I divided by 4 pi a. Sine 37 is 3 by 5. Sine 53 is 4 by 5. So I can write nu naught I divided by 5 for 20. It is 20 pi a. Then it is 3 plus 4. So the answer is 7 divided by 20. Nu naught I divided by pi a. So this is my final answer. But yeah, it is still possible to qualify any examination, but if you start now, okay? Done? Am I audible? Yes, I am audible. Now look now. Look now. Let us do some more numericals. Okay. Look now. If the wire is placed in this way, current I is flowing. So here the magnetic field would be inside. Here it will be outside. By doing the right hand, thumb in the place of current. Now you can see it is going inside by right side. So it is inside. So if you just do like this from left side, it is outside. Okay. Now if I just see it from this end, bottom view, I can write bottom view. So you can see that it is going like this. What this cross represents? Sir, current is going in this plane. Look, we were seeing a wire like this and current is going in this direction. Now I just rotate this wire in this way. Okay, so you will see now the cross only current is going into the plane. You can see now the pen is into the plane. So you can see only the tip of this pen. That means you can see the tip of the what wire only. Then tip of the wire only. Okay, so now place your thumb in the direction of current. Okay, so you will see the hand. Now look, it is going clockwise direction. It is going clockwise direction, my fingers. So you can write here, sir, my direction would be in this way. Okay, so look, this would be direction of D. Now here if you want to find the direction of your magnetic field, just place a tangent. It will be in this way, no? Yeah, place a tangent in this way. So this tangent is the direction of your magnetic field. If somebody will ask you, find here, so place a tangent, direction of your magnetic field. Here, so tangent would be here. direction of your magnetic field. Same tangent is here, direction of magnetic field. If suppose current is dot, that means you have the wire and current is out of the plane. Current is perpendicular and out from the plane. It is dot. And if you just take your thumb outside the plane, still the fingers is in the way, no? It is anti-clockwise way or counterclockwise way. So you can place it in this way. Okay. So now it is in the anti-clockwise way. Anti-clockwise means in this way. Now, if you want to find magnetic field at any particular position, it will be in this way. Be here, be here, be here, and be here. Hello, beta. So this is the way to represent the direction of your magnetic field at any point by your right hand. Then, okay, I guess it is very easy. Now let us do some numericals. Let us do some numericals. Suppose now I have a wire which is cross, that means going inside the plane. One more wire dot means going out the plane. Okay, I will just connect these two wires now. Okay, this is wire 1. You can see this one is wire first. This one means wire second. In the first wire current is I. In the second wire current is 2I. Done. At this particular point, which is P, I need to find magnetic field. If this distance from 1 is A and this distance is 9A. This one is 9A. So how we can do it? First of all, take your hand. So I just take my hand. Now place your finger, this thumb now, in wire firstly. It is going inside. Yeah, my thumb is inside. Now if we talk about the P, now look, it is inside. So stretch the fingers direction of P. P will be here. P will be here now. So magnetic field will be downwards. Look, my palm is downwards. So magnetic field will be downwards. So I can write here, sir, direction of magnetic field, that is B1 is downwards. In the same way, take your right hand. Now place at the wire second. Now you can see dot. Dot means thumb is outside. It is outside. Stretch your fingers towards point P. Yeah, I can just stretch it now. You will find this palm is downwards, right? So it is in the same direction of B1. So I can write here B2. Now we need to find out B net. So B net would be, I guess it is B1 plus B2, same direction. No? Same direction. So I need to find B1 value and B2 value. B1 and B2. Sir, what is B1? What is B1? Sir, it is nu naught I divided by 2A only. Why, sir? Because we consider them as an infinite wire. Nothing is given to us now. So just consider them as an infinite wire. Nu naught I, it is 2 pi A, no? 2 pi A. 2 pi A. Okay. Now for this one, B2, it would be nu naught I. I is 2I divided by 2 pi. Then the place of A is 9A. Okay. Now place the values here. I can write nu naught I 2 pi A. Then plus it would be I can write like this now. It is not. I'm just making these silly mistakes here. It is 2I only. I can write 2 times nu naught I only divided by 2 pi A 9. I can take nu naught I divided by 2 pi A. I will take this one is common. Internally I have 1 plus 2 by 9. So I can write B net came out to be 9 now. 9 at 11. It is 11 by 18, I guess, nu naught I divided by pi a. This is my answer. Any confusion or any doubts regarding this particular numerical? This numerical was good. Okay. So this is how we need to find numericals and how we need to find directional things. Now, in the next numerical, something is given to us. Something is given to us. Okay. So what is given to us? Look now. Same numerical, but with different things. One wire is going inside. Okay, sir. Current is I. I1 is given as 4 ampere. No issue. One more wire is given to us inside with current given as 6 ampere. Okay. Now we need to find a null point. Okay. Find null point. Those students which are watching my lecture from electrostatic, they knew this term as null point. Null point means where effective magnetic field would be 0. Okay. So suppose this one is your null point, point P. If the whole distance, it is given to us, the whole distance between these wires is 10 centimeter. So we know that from electrostatic, we need to take it from the smaller one. 4 ampere is smaller as compared to 6 one, so it is X. If this one is X, so I can conclude that this one is 10 minus X centimeter. Done. Take your hand for directional things. Now, on the wire, firstly, just take your thumb inside it. So my B1 would be downwards. So my B1 is downwards. Okay, sir. Take my hand inside. So at B, it is upwards. So at B, it is upwards. And we suppose that this one is a null point. If null point, so what is B net now? So B net is 0. If it, where is assuming it now? Where is assuming it? Yes. Okay. What is B1 now? What is B1 now? So B1 is nu naught I. I is 4 ampere divided by 2 pi, distance is X. Done, sir. What is B2 now? It is nu naught into 6 divided by 2 pi X. X is not X, it is 10 minus X. B net is 0. If B net is 0, so you can write that it is only possible when B1 is equals to B2. What is B1? Sir, B1 is nu naught 4 2 pi X. Nu naught 6 2 pi 10 minus X. Nu naught cancel out. 2 pi cancel out. So you can write 40 minus 4x equals to 6x only. I guess 40 equals to 10x. So x came out to be 4 centimeter. So we can see here, this is 4 centimeter. So this would be 10 minus 4, it is 6 centimeter. So the null point on this line is 4 centimeter from the 4 ampere and 6 centimeter from the 6 ampere. This is how you need to calculate these numericals. I hope this one is very, very, very clear to you, right? This one is very clear to you, very, very, very. Okay. Let's start now. Next one. Next numericals. Okay. Next numerical. We are having wires. Dotted means infinite wires. Current I is 9 ampere. One more wire, which we suppose it to be the infinite wire. Current is flowing 2 ampere. Distance between these two wires, it is given to us, which is 2 meter. Okay. We have a point here, this point. point P. Here I need to find B net. And this point is 1 meter. This point is 1 meter. So we need to take our hand. Okay, sir, take this hand on the first wire. Okay, so the thumb will show you the direction of your current. 9 ampere is going upwards. Now this finger should be towards the point where we need to calculate magnetic field. Okay, it would be like this now. Look, this particular hand palm is inside. That means my B1. B1 B1 means magnetic field due to first wire would be inwards. In the same way, take your hand, place the finger in the direction of current upwards. Now this stretch your fingers towards the P. Now it is insert inwards also now. So B2 is also inwards. Okay. So what will be the value of B net? Sir, B net will be equals to B1 plus B2. Okay. So what is B1 now? Infinite wire, nu naught I divided by. So we have here distance now. So I can write now I is not I, it is 9A. I will write directly it is 9 divided by 4. But I will cut it, it will become 2 pi. Pi distance is 2 plus 1 is 3. It will be 3. Then what is B2 now? Nu naught 2 divided by 2 pi. It is 1 only. So now what is B net? I will place the value of here. It is nu naught into 9 divided by 6 pi plus nu naught 2 divided by 2 pi only. I will take nu naught divided by 2 pi common. So what we have, it is 9 divided by 3 plus, so it will be 2 only. Then I can write nu naught divided by 2 pi 9 plus 6 divided by 3. So it would be 15 divided by 6 nu naught by pi. 3 to the 6, 3 5 the 15. I will write 5 by 2 nu naught by pi. So this is your answer. This is how you need to do your numericals. If you are having any confusion, anything like that, you can ask me. Okay, I will just, you can take this screenshot or whatever you want to like. At the end, after completion of one chapter, I am sending these notes in my Telegram group. Okay, if you want these notes, you can join the Telegram group also. And for all these updates. Now look, now one more numerical. So we are having, one second. Okay. One more numerical that we are having wire. Suppose infinite wire. Coming from infinity goes towards infinity. One more wire. Coming from infinity goes towards infinity. Okay. And in this one, 2 ampere current is flowing. In this one, 3 ampere current is flowing. And both these wires are 1 meter apart. So I need to find out a null point between these. So this one is smaller one. I will write here, point P is here. So this distance would be x. So this one would be how much? 1 minus x. Okay. Now let us take the hand. Now 2 ampere is going upwards. Stretch your fingers towards P. Now my B1 is inwards. So B1 is cross, inwards. Now if you take, now you can take 3 amperes outwards. Now P is in this way now. So my hand is outwards now. This is inwards, my outward B2 is outwards dot. So what is B net now? Okay, it should be 0. That means it is only possible when B1 equals to B2. Now what is B1? For infinite, it is nu naught I is 2 ampere, it is 2, divided by 2 pi d. D is how much? It would be x only. Equals to nu naught I is how much? 3, divided by 2 pi 1 minus x. Done. 2 pi cancel out. Nu naught cancel out. So I can write 2 ones are 2 minus 2x equals to 3x. So 2 came out to be 5x. Therefore, my x came out to be 2 by 5. 2 by 5 meters. 2 by 5 meter, which is approximately equal to 0.4 meter. So this distance would be 0.4. So this would be 0.6. Done? Any confusion now? No confusion? Okay. If no confusion, let's start second application part. Second application. It is magnetic field due to circular arc at the center. We had discussed these cases in the previous chapter, that is electrostatic. Now we are just repeating these things. If we are having a circular coil or a thing like this, okay, this would be a center. I need to find out magnetic field in net at the center. This angle is theta. This is radius r, radius is r. Done. So if, let's suppose we will take a small element here, small element, current I is flowing. So current I is flowing through this small element, element is dl. Distance would be r only, no? R only. Okay. So what would be the small magnetic field due to this small element? Sir, it will be nu naught. Current is I flowing divided by, it is 4 pi. Okay, we are using the law. Then we have dl r sine theta divided by r cube. Okay. We know that every time, look, this is going like this, and you can see angle is 90 degree. Angle is 90. So can I write now? It is nu naught I divided by 4 pi dl. dl is the small element. Okay, dl. I will write dl as it is dl. 1 r cancel out, so I can write r square. Then we have sine 90, and sine 90 is 1. Sine 90 is 1. Done? 1. So what I can do right here now, I need b. So I can write b. Look, nu naught is constant, I is constant, 4 pi is constant, r square is also constant, integration of dl only. So it is small element. Okay. So can I write now? Arc length equals to radius into angle. One formula. This is one formula, no? Okay. Now arc length is dl. It is dl. Radius is r. Angle is theta. So in place of dl, I will write r theta. So can I write now b equals to nu naught I divided by 4 pi r square multiplied by r theta? Yes, sir. R cancel out. So my net field at the center will be equals to nu naught I divided by 4 pi r into theta. One thing that you need to remember, that theta should be in radian only. It should be in a radian only. It should be in a radian only. So this formula you need to take up in your mind, sir. It is nu naught I 4 pi r multiplied by theta. Previously it was nu naught I 4 pi r sine theta 1. sine theta 2. Now we may be having a different cases. First case. First case, case number first. Case number first means if we are dealing with circle. If we are dealing with circle. Okay, sir, no issue. So if we are dealing with circle, so could you just tell me what is theta in circle? Sir, in circle, theta is 360 degree. 360 means it is 2 pi radian. It is 2 pi radian. So can I write B equals to, it is nu naught I divided by, it is 4 pi r theta, theta is 2 pi. Okay, sir. Pi cancel out. 2 ones are 2, 2 2 are 4. It is equals to nu naught I divided by 2r only. So magnetic field at the center of a circle is this much. Then now case number second. Case number second means if we are dealing with semicircle. Semicircle. So for semicircle, theta is 180 degree. 180 means it is pi radian. If it is pi radian, so my magnetic field will be equals to nu naught I divided by 4 pi r into theta is how much? It is pi only. Pi cancel out. So my answer came out to be nu naught I divided by 4r. Divided by 4r. Okay. Now, case number third. Case number third. Quadrant. Quadrant means 90 degree. If we are dealing with theta if 90 degree. 90 degree means it is pi by 2 radian. Pi by 2 radian. B equals to, it is nu naught I 4 pi r into pi by 2. Pi cancel out. So my answer came out to be nu naught I divided by 8r. Next one. Case 4. Case 4 means if we are having theta equals to 270 degree. That means, look, this angle is 270. So you can see here, theta is 3 by 2 pi radian. So B equals to nu naught I divided by 4 pi r into 3 by 2 pi. Pi cancel out. My answer is 3 by 8 nu naught I divided by r. Next answer. Then look, in these 4 cases, we consider that circle is of one revolution. One. But it is not compulsory always that it is only one revolution. It is only one turn. You can see now, look, what I want to just show you. Look better. Okay, look. This one is also circle. Okay. Also circle. So what is different between these two? Number of turns 1. In this, number of turns 2. In the same way, if number of turns are more, so what you will write? You will write n times nu naught I divided by 2r. Okay. This one, n times nu naught I divided by 4r. This one, n times nu naught I 8r. N times 3 by 8 nu naught I divided by r. Done now? Done. If you have any doubt, you can ask me now. If not, then we will do some numericals then. We will doing some great numericals, some great and good numericals. Look now. Look now. we are having concentric circles. We are having two concentric circles. Concentric means same center. Okay, sir. It's common center. Current I1 is flowing in this way, clockwise way, and current is same. I2 is flowing same direction. Small one is having radius R1. Big one is having radius R2. Done. So what will be the net effect of your magnetic field at the center? I don't know. Take your hand. Okay, sir. Okay. Current is going in this way. So it will be inwards. No? Look, place your thumb in the direction of current. So palm is inside the center. So you were right. B1 is inwards. Say B2 is inwards. Done. So I will write B1. B1 is how much? It is circle. Circle, na? One turn, it is nu naught I1 divided by 2R1. It is inside. Okay, sir. What is B2 now? B2 is same. Nu naught I2 divided by 2R2. It is also inside. So therefore, I will write B net is equals to nu naught I1 divided by 2R1 plus nu naught I2 divided by 2R2. So I will take nu naught divided by 2 common. I have R1 I1 by R1 plus I2 by R2. So this one is my final answer. Final. Done? Praveen, after completion of my 12th standard, I will start my 11th one. That means in next month, I will be completing 12th, then I will start 11th. Okay? Look now. One more numerical. This is PYQ. You can just see it. Look now. Okay. So we have a numerical like this. Current, look now. Current I is flowing in this way. So here we have current I1. Upper one, we have current I2. This is my central point. I need to find here B net. Look now here. If radius of inner one is R1, radius of outer one is R2. Look, see here. If we are talking about this wire, so this point is coming in the axial position, and we know that axial position B is 0. Okay. Now, if we talk about this wire, it is also lying in the axial position, so B is 0. So now we are left with two semicircular coils. Semicircular coils. So what will be the semicircular coil B1? Okay. So B1 is nu naught I1 divided by, it is 4R1. Direction is inverse, we know it. B2 nu naught I2 divided by 4R2. Direction is inverse. So if both are inverse, so what will be B net? Sir, B net would be nu naught I1 divided by 4R1 plus nu naught I2 divided by 4R2. So I will take nu naught divided by 4 common. So we are left with I1 divided by R1 plus I2 divided by R2. This one is my final answer. So let us suppose we will change the direction of current. Suppose we will change the direction of current. How, sir? Look now. Same numerical, but only change in the direction of current. Look now. Central point. I1 is in this way. I2 will be in this way. R1 radius, R2 radius. Okay. So we know that, sir, if we talk about this one, still my B is 0. my B is 0. If we talk about this one, settle sir, B is 0. Take your hand, B1 will be inverse, right? So B1. So B1, I need to write it like nu naught I1 divided by 4R1. It is inverse. Cross is inverse. B2 would be nu naught I2 divided by 4R2. It will be outwards. Now, what is B net? Is B net B1 minus B2 or B2 minus B1? So you will write big minus small, big minus small. Okay, we know that R2 is more than R1. You can see from the figure now. So therefore, B1 is more than B2. So I can write B net is equals to B1 minus B2. So what is B1 here? So B1 here is nu naught I1 divided by 4R1 minus nu naught I2 divided by 4R2. So therefore, my B net came out to be nu naught by 4 I1 by R1 minus I2 by R2. This one is my answer. And yes, dominant would be B1. B1 is inverse, so direction is inverse. Dominant would be the bigger one. Okay. Okay. Let's do one more numerical. One more now. If we are having a numerical like this, look now. A wire coming, it is infinite wire. Assume that it is infinite wire. It is now turning in this way. Infinite wire. Okay, if current I is flowing, so same current will flow through this semicircular part, same through this one. And if this side is A, suppose. Now I need to find a magnetic field at here. You can see we have three components. One component, two, three. One is semi-infinite wire. Semi-infinite wire. This one is, second one is semicircle or semicircular ring. Third one is same semi-infinite wire. Done. Now let us talk about the direction. B1 is inverse. So you can write here, sir, B1 is inverse. Same, B2 would be also inverse. Okay, sir. And B3 is also inverse. You can take your right hand, you can just get the direction, right? Okay. So what will be now B net? Sir, B net would be B1 plus B2 plus B3. Okay. So B1 is here now. So B1 I will write as semicircular part. B1 is my sorry, it is not, it is semi-infinite part. Okay. So I guess semi-infinite part means nu naught I, it is 4 pi a sine theta 1 plus sine theta 2. So it will be equals to, it is nu naught I divided by 4 pi a. A is only A, right? Done. And it is inverse. Done. What is B2 now? It is semicircular part, and that is nu naught I divided by 4 pi. What we have? Theta, R theta, right? Theta is how much? Pi only. So I can write nu naught I, it is 4a cross, and this is B3. B3 would be same. It is nu naught I divided by 4 pi a. It is cross now. So B1, nu naught I 4 pi a plus nu naught I 4a plus nu naught I 4 pi a. Done. So I will take nu naught I by 4a common. Then we are left with 1 by pi plus 1 plus 1 by pi. So I can write nu naught I divided by 4a. 1 by pi is 2 by pi plus 1. It is B net. These are very simple numericals, and these are PYQs only. These are some PYQs. So we are having, the class will be up to the 12 o'clock. Okay. So let us do one more numerical, a good one, numerical. Okay. So what is a good one numerical, sir? Look now. We are having 3D x-axis, y-axis, z-axis. X means plus I cap, y means plus j cap, z means plus k cap. Now we have a wire. Wire is coming in this way. It is an infinite wire. Then here it is semicircular part. It is going in this way, coming in this way, leaving parallel to my z-axis. At the center, I need to find my B net. If this distance is a this distance is 2a, current I is flowing through the wire. Look now, you can see this one is on the actual point. So if we talk about this particular thing, so B is 0. Then look now, this one is also on the actual side. So B for this one is 0. This one is it is a quadrant, no? Quadrant. So for quadrant, what is the value? It would be quadrant, no? So quadrant is, look, nu naught I divided by 4 pi r. Quadrant is pi by 2. I will write pi by 2. Pi cancel out. It is nu naught I divided by 8r. I can write it is nu naught I divided by 8r or 8a. And it would be inverse. Inverse means cross. Cross simply indicates minus k cap. Okay. This one, same quadrant. I can write nu naught I divided by 8, but we have 2a now. It would be inverse also. Inverse, yes. Inverse means minus k cap. This one is my semi-infinite wire. So for that one, it is nu naught I divided by 4 pi a. What is a? A will be 2a only, no? It is 2a. Then it would be where? In this way, it will be minus j cap. Minus j cap. So what will be now B net? Sir, B net, if I need to write it, it would be nu naught I divided by 8a minus k cap plus nu naught I divided by 8 2a minus k cap plus nu naught I divided by 4 pi 2a minus j cap. This is my answer. You can simplify it also, no? There is no issue. You can simplify this one also. Okay? You can simplify this one also. Let us do one more numerical. If we have a numerical like this, look down. Okay. Current I is flowing. Central point, which is r distance apart, we have to find magnetic field. So what we can do now? I will just assume two equal and opposite elements here. Opposite. So by placing these elements, so I will merge this one with this one with this one. So it will looks like now like this. Look now. Now we have now two pieces. One is circle, one is circle, one is infinite wire. This distance is r. The circle will give me B1, wire will give me B2. Clear? Look, if we talk about the direction, no? Direction. So as per this one B2, so B2 will be how wire? It will be outwards. And B1 will be inwards. It will be inwards cross. Done? But we need to find out which one is a bigger quantity. Okay, so what is B1 now? B1 is the circle one. B1 is the circle one, that is nu naught I divided by 2R only, which is cross. What is B2 now? B2 is nu naught I divided by 2 pi R, which is outwards. So you can see now, look, it is nu naught I 2R. 2R is more than, nu naught I by 2R is more than 2 pi R. So clearly it is B1 more than B2. So what is B net now? So B net would be B1 minus B2. B1 is nu naught I divided by 2R minus nu naught I divided by 2 pi R. I will take nu naught I by 2R common. So I will got here 1 minus 1 by pi. Done? Yeah, it will be inverse because B1 is inverse. Simple? Simple now? Okay, let us do one more concept. A very good concept. New concept. New concept is we are having a fixed length wire. Fixed length wire. Now we bend this wire into circular loop. Circular loop. That means if we are having a wire, this wire, current I is flowing, and this wire is of L length. Now we bend this one in the form of loop with radius R. Done. So if let us suppose this wire is having n turns, we don't know no n turns. So I guess the length of the wire and the circumference of this one is equal 2 pi R. But if it is n times, it is equal. Okay. So look here, 2 is constant, pi constant, R constant. R is not constant, but R is changing. Why, sir? I can make a small, I can make a big. Okay. I can make a small, I can make a big. If the radius is small, number of turns will be more. If the radius is more, number of turns will be less. So L is fixed now. So therefore, can I write now number of turners is inversely proportional to the radius of your loop? Yes. Sir, how? Look now. If we are having 1 meter wire, I can change it and make a very big one with one turn. One turn. Either I can make it looks like small and with 10 turns. That means more radius, less turn. Less radius, more turn. It is the meaning of this particular thing. So if you need to find out magnetic field at the center, for circle it is n times nu naught I divided by 2R for center. Okay, sir. Nu naught constant, I constant, 2 constant. So can I write now B is proportional to the n divided by R? Okay. So B proportional to the n. What is R? Sir, R is also, I can write 1 by n. No? So therefore, magnetic field at the center would be proportional to the n square. This result you need to remember. That means if we are having fixed wire length and we are just bending it to a circular loop, magnetic field will be n times. My magnetic field will be the n times. Let us do a numerical from the NEET. We have a numerical from the NEET. Okay. Numerical from the NEET. Numerical is like, I will write the language of numerical so that you can just assume it, how the question could be framed for it. A long wire carrying a steady current. Steady current means which is not changing. Steady means which is not changing the DC current. Okay. A long wire carrying a steady current is bent into a circular loop of one turn. The magnetic field at the center of the loop is B. That means we have a wire. We now bend this wire with only one turn, and we find the magnetic field at the center is B only. It is then bent into a circular coil of N turns. The magnitude of magnetic field at the center of a coil of N turns will be. Now, how we need to solve it? Okay, when my number of turns is 1, my B1 is B. When my number of turns is N, I need to find out B2. We know that B is proportional to the L square, N square. So B1 divided by B2 equals to N1. N1 square divided by N2 square. So B1 by B2. Hello, beta. What is N1? N1 is 1. N2 is how much? Only N, it is N square. So therefore, B2 came out to be N2 times B only. Okay. I guess within 20 seconds, you can get your answer. Within this particular time, now you will get your answer. Okay. Done? Okay. So before couple of minutes, we were discussing about the loops. Previous part, no? We were discussing about the loops. But if you had noticed that loops was concentric, no? Like this, concentric in one plane only. These are concentric. Okay. Now I can make the loops like this. Now one loop is in this plane, one loop is in this plane. It is also possible. This is my center. Okay, now one loop is in this way, one loop is in this way. I need to find magnetic field at the center. If current, no beta, it is free. All these lectures are free. If I current is flowing in one loop in this way, and similar I current is flowing in second loop, how to find magnetic field? I will take these as a separate one. Now look, now current I is flowing. So what will be the magnetic field? Sir, I will take my hand. Okay. So current is going this way, and my this tip should be towards center. My palm is upwards. So you can write, sir, my B1 will be the upwards. Done. B1 is upwards. Got it? Now we have one more. Current I is flowing. This is my center. Now take my hand. Okay. This thumb is towards the current, finger towards the point. My palm is in leftwards. So my magnetic field will be here, B2. Now combine these two. So you will get B1 in this way, B2 in this way. And the angle between them is 90 degree. So from vectors, what will be the B net mod? Sir, it will be B1 square plus B2 square plus twice AB. It is not AB, it would be B1, B2, no? It would be 2 times B1, B2 cos theta. Cos theta, this would be cos 90 and cos 90 is 0, so the whole term will get cancelled out. So my B net came out to be B1 square plus B2 square root. This is my answer. Easy? Easy or super easy? Huh? Easy or super easy? We will do a couple of numericals. As you know that the class will end at 12 o'clock. So we are having a couple of time now. So we will discuss some more important points. Okay. Okay. So let us do one more numerical based on this particular property. Let us do one more numerical. And I will write the language of numerical. Okay. Look now. Two similar coils of radius r are lying concentrically with their planes at a right angle to each other. Concentrically means center coincide of both the wires, of both the loops. The current flowing in them are I and 2I. The resultant magnetic field at the center will be. Okay, so I guess we derive now the formula B equals to B1 square plus B2 square root. Done. What is B1? These are what these are? These are coils. Coils means circle. So for circle, it would be nu naught I divided by 2R only. Okay. So B1 would be nu naught I divided by 2R whole square. B2 is nu naught I divided by, we don't have I, we have 2I. Now I will write I2 like this. Then we have 2R whole square. Then root. बेटा मेरा आयुष बोलने से क्या होगा आपको? हा? आयुष गर्ग है यहाँ पे क्लास में. बस बेटा खुश. So अब यहाँ पे देख लीजिएगा आप. So I will take nu naught I divided by 2 are common. It could be common, no? So internally what we have now? 1 plus, it will be 2 to the 4 root. 4 plus 1, it will be root 5 nu naught I divided by 2R. This is my answer. This one is my answer. Done? If any doubts with this particular numerical, you can just let me know. Any doubt? No doubt? Okay, let us do one numerical from JEE also. Let us do a numerical from JEE. Okay, it would be a plus numerical with some more informative things. So we are having a current loop consists of two identical semicircular parts, each of radius r. One lying in the x1 plane and other in xz plane. If the current in the loop is I, so find net magnetic field at the common point. Okay, as per question, we need to draw a coordinate system firstly. X, Y, Z. This one would be XY plane and this one is XZ plane. So one will be in this way, one will be in this way. Okay, these are similar. So here, if current is so, if radius is same, na, if R and R, okay. So B1 would be this one and B2 is this one. Look, both are identical. Identical means both magnetic field same, B and B. So what is B now? B net now? It will be B1 square plus B2 square. I can write B square plus B square root. So my answer came out to be B root 2. It is B root 2. Okay. And we know that what is B for a semicircular coil? What is B for that? It is nu naught I divided by 4R, then it is root 2. If you need to further simplify it, you can simplify it. There is no issue. You can simplify it now. How? By 4. I can write it what? 2 root 2 root 2. I can write it like this now. Look, nu naught I by 2 root 2 root 2 R. Root 2 into 2. 2 to the 4. I can write it like this now. Root 2. Cancel out. So my answer came out to be nu naught I divided by 2 root 2 R also. One is the same thing now. Done, beta. Subhajit Kaur. Good question. Nice. Thank you, beta. It is very easy to manipulate now. Why, sir? Because basic we know now, na? Look, we started the class. We started with the class with basic things. Look, now how many numerical we had done? Okay, we start with the magnetic field at the center part. We done this part. Okay, we derive the formula, I by 4 pi r the theta. Then how to do for circular, semicircular quadrant. Okay, then we done couple of numericals based on these particular numericals. So now we come to this one. So we are increasing the level plus 1. We are starting the basics, then going with the tough numericals. So by this thing, na, you will get your base cleared. You will get your numerical also clear, right? And you won't feel any toughness in these things. Why? Because we are going smoothly we are going with smooth transition from not knowing something to knowing something. Okay. Next part, we are having null point. Heading is location of null point. Null point means magnetic field is 0. If we are having a wire, this is my wire, current is I1 flowing. We are having one more wire. These wires are not touching to each other. That's why it is some semicircular part. Current I2 is flowing. Now, how many parts we have? We have one part. We have second part. We are having third part. We are having fourth part. Now, here we have a point or any point. I won't specify any point in first quadrant. We know that I1 current is flowing upwards. So what will be the direction of magnetic field in first one? Definitely better. So look now, place your fingers towards the I1. Okay. Now, in first quadrant, your palm is inside. So that means you will write, sir, B1 would be inside. Cross. Now 2. I2. Now place your finger towards I2. Now, but this tip off should be toward direction of 1. So it will be like this. Now you can see now. You can see the palm is towards your face, that is outwards, dot. So my B2 would be dot. Dot. In the same way, here I1. I1 would be how much? I1 would be outwards. Similarly, I B2. B2 would be outwards. In like this. Yeah, outwards. In the 3 region, I1 would be outwards, but B2 would be inwards. In the fourth one, I1 is inwards, I2 is also inwards. You can see now, here, not possible to get my B net equals to 0. It is not possible. But every time B1 would be plus with B2, na? It is not possible to get B net as 0. Same here, direction same, so B net is not possible to get 0. That means only in this way or in this quadrant, it could be 0. It could be 0. Done? If suppose we are having a point here, quadrant of this particular point is x and y. That means this is x, this one is y. Then suppose B is 0 here. Suppose B is 0. Suppose B net is 0. Possibility is there, no? That means B1 should be equal to B2. Okay. What is B1? B1 is magnetic field due to firstly. I can write it is nu naught I1 divided by 2 pi, distance is x. Okay, sir. This one, it would be nu naught I2 divided by 2 pi y. Now see, nu naught cancel out, 2 pi cancel out. So by this one, I conclude that I1 by x equals to I2 by x. Sorry, y. I2 by y. So now, I guess this is visible to you now. Okay, I will write here. So I can write now y is equals to I2 by I1 into x. Now just compare the equation with the y equals to mx plus c equation. So you can see here c is equals to 0. My slope m came out to be I2 by I1. Okay, so it is a straight line. That simply indicates if we are having something like this, straight line crossing 0, crossing from origin. It is origin, no? Straight line crossing from origin with the slope I1 by I2, any point. Okay, you can write every point or any point. Every point on this line is null point. Is a null point. Done? Easy? So every point on this line shows what? It is a null point. Easy? Let us do a numerical. Let us do a numerical based on this particular concept. Do a numerical. Let us do a numerical. Numerical is like, so we are having a system. Current I is flowing. Current I is flowing. AB, CD. Give me the wire or line AB or CD on which we will get a null point. Simple. If current is I is going in this way, so B1 is outwards, B2 is inwards. Here, in this way, so B1 would be outwards, B2 would be outwards. Not possible. Here, B1 is outwards. No, it is out inwards. It is outwards. B1 is outwards. B2 is inwards. Possible. B1 is inwards. B2 is inwards. Not possible. So it is AB. So we have to apply the formula like this way. Okay, so we are dealing with a very good concept, a very great concept, null point. How to get the null point? We discussed this thing in previous chapters also, like in electrostatics. Now we are dealing with this one also. Now last topic, then we will end the class. Last topic, last topic. Last topic is, if current divide in a regular shaped loop of same material, then net field or net magnetic field at center is always zero. This statement you need to remember. That means if we are having a regular shaped loop, means circle, means square, material should be the same. That means row same, area same. The net magnetic field at center is zero. So what is the meaning of it? Let's suppose we have something like this. Okay, easy. This is my center. It is not my center. This is my center now. Okay. Okay. My current is I coming, and you can see current is divided into two passes, I1 and I2. Here current I will go back. Then that means we are having a battery here somewhere with V potential difference. I guess if let us suppose this angle is alpha 1, this angle is alpha 2, alpha 1 and alpha 2. So condition is that should be there, sir, same material. If this thing is written in the numerical, then you need to write this formula: uniform wire. Uniform wire. Uniform means area of cross section is same. Then one part, one more part. So what is B1? So B1 is magnetic field due to the upper portion. Okay, no issue, sir. I guess it is an arc now. If it is an arc, so I can write nu naught I 1 divided by 4 pi radius is r. It is what? Alpha 1. It would be the inverse. Done, sir. B2 would be, it is nu naught I2 alpha 2 divided by 4 pi r. It would be the outwards. And it is always 0. 0 means B1 should be equals to B2. Hello, Shiraz beta. B1 should be equals to B2. Now, what is the meaning of all these things? Look now. Look now. I guess these two things are in parallel. This part and this part, it is in parallel. If these two are in parallel, can I write now V1 is equals to V2? Okay. What is V1? Is it I1 R1 equals to I2 R2 by Ohm's law? Yes, sir. Done now? Done now? Clear? Okay. Now, V is equals to current into I into R. V is same. Can I write now, sir, I current is inversely proportional to the resistance? Yes, sir. But resistance is equals to resistivity L by A. Area is same. Material is same. That means resistance is proportional to the length. I can write equals to 1 divided by length also. I can write like this now. Okay. One more thing. What is it? That arc is equals to r into theta, radius into angle. Radius into angle. Done. What is arc? Is it length? Radius is same, so length is proportional to my theta. Angle also, no? It is angle also. I can write it, I is inversely proportional to the L, R, and L is directly proportional, and L is, and angle is proportional. I can write it angle. This thing you need to remember. Done? Clear now? Okay. So look now. What is B at center? B at center? Is it B1 minus B2? B1 minus B2. Why sir B1? Why not B2 minus B1? Because alpha 1 is more. What is B1 now? Is it nu naught? I1 alpha 1 divided by 4 pi r? Yes sir. Minus nu naught I2 alpha 2 divided by 4 pi r. Done sir. B at center. I will take nu naught divided by 4 pi r common. So can I write here? It is I1 alpha 1 minus I2 alpha 2. Okay. So take this one now. We know that radius, so resistance and angle both are proportional to the each other. Proportional. I can write this equation as a I1 alpha 1 equals to I2 alpha 2. Both are same. Therefore, I1 alpha 1 minus I2 alpha 2 equals to 0. So this term came out to be 0. Therefore, B at center is 0. B at center is 0. Simply means that if we are having a regular shaped loop of same material with uniform area of cross section, uniform area, so magnetic field at the center is always 0. Always, always, and always 0. Suppose you will get a numerical. You will get a numerical, and it is very famous numerical. Okay. One numerical. Find magnetic field at the center. And conditions are given now. So, sir, we know that B at center is 0 for this one also. B at center is 0 for this one also. B at center is 0 for this also. So it doesn't depend on the angle. Now, if angles are different, no issue. No issue. It doesn't depend on it. It doesn't depend on it. Done? Any doubt now? So we are done with lecture number 2nd. So Monday, most probably, we will be dealing with lecture number 3rd. And we will try to complete the whole chapter in next week. Yes. Next week, most probably we will complete it. Okay. In 7 days, or I guess in 7 days, we will complete the whole chapter, next week. So we are having the plan now to complete the whole syllabus before September, so that we will start the in September 11th portion also. Okay. If you are having any doubts or if you want to ask me anything, you're most welcome. If not, then bye. Good night. I don't think you are having any issues or anything like that. So I will just check it out now. Then good night, beta. Thank you. Bye. Good night.